An interesting paper. Fong raises objections to my approach to English modals and modality in general, which he views as too general and not fully compliant with the postulates of construction grammar. In this response paper, I intend to explain in some depth the benefits of my approach, as well as the reasons why construction grammar, in particular cognitive construction grammar, needs to be interrogated and adapted as a conceptual framework to explain language learning and processing. This response paper draws on three main innovations announced in my 2019 paper. Constructions are triads of form, function, and agency that arise out of the conjunction of specific constructional attachment patterns, that is, embodied constructional arrangements organized in both high-level, e.g. abstract syntactic patterns, and low-level constructions, e.g. words, morphemes, affixes, etc., in networks of interconstructional relations motivated by agentive selections. The combination of modal clusters with specific argument structure constructions provides a sense of systematicity in the description of modality in English. Thus, the function of ACCs is to encode and organize common signals that need to be expressed linguistically. This becomes clearer if one brings into discussion the ways how the process of signal recognition in language depends on several particulars, namely what the decider knows, his or her expectations and beliefs, how later information affects the interpretation of the original observation, and the like. These particulars are guided by two basic embodied reenactment principles, whereby concepts rely on simulations of experience. 1. Exteroceptive signals coming from the environment motivate modal reenactment emotional events, including lexical priming. 2. Interoceptive signals coming from the inner body motivate emotional reenactment. Balance and self-stabilization are often the result of emotionally arousing stimuli in non-emotional events. Multisensory information leading to representation begins with a series of top-down expectations which are then confronted with bottom-up sensory prediction errors, posteriors, with statistical relevance. As a result, hierarchical optimization of precision naturally motivates an account of both endogenous and exogenous attentional spotlight effects. In order to construct a representation, agents need to combine hypothetical information regarding the behavior of, for example, Dilophosauruses, with all real-life reference frames involving, for example, knowledge of modern-day reptile behavior or some emotional content associated with dinosaurs in general. This results in the joint reconstruction of reality through the brain-body interface. For instance, modern-day conceptualizers familiar with films like Jurassic Park, in which these predators are depicted as small, venomous carnivores equipped with a retractable frill, would use these priors to identify a representation of the animal. A mismatch between these priors and the incoming sensory prediction errors about the form of a Dilophosaurus may result in a new set of more correct guesses. These create mental schemas that may yield a set of hypotheses that include senses of movement, trajectory, force, barrier, etc., which can be encoded in utterances such as Dilophosaurs were middle-sized, non-venomous solitary hunters.